Yeah, hello and good afternoon. My name is Dirk. I'm a global partner solution architect with the Exasol company. And today I want to show you my presentation, Future-Proofing Your Database, Implementing Flexible Extensions with Exasol User-Defined Functions. Some words about me. As mentioned before, I'm working as a global partner solution architect or sales engineer, maintaining on a global basis all our partners. I'm working in the data analysis arena since the late 90s, concentrating on all different aspects of business intelligence and data warehousing, including databases, the loading side on the client side. And I'm also have worked in the structured as well as the unstructured data world. With Exasol especially, I'm specializing in machine learning and artificial intelligence, and I'm with Exasol for nearly 2 years right now. What we're going to see today, first of all, I want to give you some motivation about the user-defined function framework. We have to talk about so-called script language containers, which are the core, the heart of the user-defined function framework. I want to go into user-defined function and what does it mean for you, finishing this up with a live demo and a questions and answers section. Some words about the motivation for today's presentation. In 2015, Exasol would have been able to infer, or in other words, execute large language models in the database. And while you're reading this, I'm pretty sure some will raise their eyebrows because what is Dirk telling about? Yeah, and you are right, because large language models started to appear during the year of 2017 with a famous paper, Attention is All You Need, by some researchers at Google. What I want to say with this is that we were able to do certain things in the database even without knowing that this is coming or becoming the next future trend. Also, what I want to say with this is even for things we don't know that they will exist in the future, we are pretty sure that we can utilize it in our database if feasible. So what are the key attributes? And they are definitely not complete, but most people are talking about speed when they're talking about databases. The faster the database, the better. Self-tuning, which means a database should be like a black box, should correct itself, should tune itself, and obviously it also should be capable with working with large data. Nobody or only a few people are talking about the so-called user-defined functions or user-defined function frameworks. But this is a really important because this is a very good approach to individually extend the database capabilities. So we don't only want to grow with you by speed or by amount of data or the amount of users. We also want to grow with you by the number of use cases. And sometimes a new use case requires functionality out of a database, which is not included in the database at the point of time when you bought or acquired the database. How we are doing this with the so-called script language containers. First of all, from the architecture side, you see a diagram you probably will see with every other database vendors. We have some control nodes, we have some disks and data storage. But really important is here we have a container section, basically Docker containers, which are added to the database. And each of such a container is bearing a so-called script language environment. Can we use more than one script language environment? Absolutely. But why should I consider to have more than one language environment? Firstly, for compliance reason, different departments need to be segregated from each other in terms of functionality. Or even more important, you have package dependencies in different use cases you cannot resolve with only one Docker container. So you can use several ones for each use case. But why containers? They are flexible, they are isolated, and we do not even rely on a script language environment from the host operating system. We have our own one. And this is really important for security reasons. If the host gets compromised, our language container are not compromised. So we can even ensure data integrity here. What are the supported languages? First of all, if you're going up to the upper right box, Lua. Lua is a script language native with the database. It's really, really the fastest option you can get for scripting inside the database. However, it has only a fixed set of packages. What does that mean? If you need a certain other package, you have to go to R&D. You have to beg R&D that you're including a new package into one of the next databases releases. So this is definitely nothing if you need speed and flexibility in your development process. The most preferred language or scripted language for Exasol is the Python language. You can have different Python versions and Python packages in a language container. It's flexible and it's extensible at your own needs. And it's our own preferred language, for example, for the Exasol AI Lab. If you do not like to code in Python, we offer also Java or the language R if you want to do artificial intelligence projects or machine learning projects. Extensibility. Once again, we are augmenting the database capabilities based on Docker containers. They're easily extensible by a command line interface or through the Exasol AI Lab. You can have multiple topic-specific containers which can resolve package dependencies. We are separated from the language environment of the database host for the reason of data integrity and data security. And most importantly, they are only on standby when not needed. So they are not consuming any kind of resources in terms of, for example, CPU or RAM. You can activate a language container globally for every single user, being available at any point of time or per user session. And not to forget, Exasol is a so-called MPP architecture. MPP stands here for Massive Parallel Processing, which means automatically all these scripts coded with the script language environment, so our user-defined functions are running in parallel over all the different nodes of an Exasol database cluster. And you have nothing to do for it. It's coming for free. So what do we need to do to create our own language container? For example, you need a Python package which is not included in the standard language container. I've given you the 2 steps. The first step is you add here the OpenAI package, which I'm going to use later on. And secondly, I'm telling the AI Lab it should export the new language container. What happens then is a process taking between 10 to 15 minutes, building a complete new Docker container, uploads it to the database, and makes it ready to become activated at any given point of time. So how does the user-defined functions look alike? We have 4 different types. On the input side, which are the parameters of a function, you can have just some input variables like base price, like distribution cost, like age, or you can have an entire result set from a SQL statement. On the output type, you have the option to return just a single value, or again, to update and to return a complete result set. So for example, if you want to have a Scala input, a few variables, and only a single output type, like in varchar, like in integer, you can do something like line-by-line processing. If you specify a data set returned from a SQL statement and only a single value, this is a perfect way to write your own aggregation function if you need something besides min, max, count, standard deviation, or similar. So the combination of input and output types cover all aspects of what is needed for a user-defined function. To make it easy for you to start with a user-defined function, we have on our website a so-called signature generator, which generates a skeleton on what you have to do in order to write a good UDF. You can select between the Python 3 language, which is coming out of a container, the Lua language, which is native in the database. So this does not even require a Docker container, Java or R. You specify the input type. In my case, Scala, I'm just giving some parameters, and you can see this later on in the demo. And I'm returning just a text. So, which is basically a line-by-line processing, which is the first line here. If you want to photo the QR code, this will bring you directly on our webpage to the signature generator. Of course, you have to activate the system or the Docker container. This is a little bit cryptic. With an alter statement from SQL, of course, you have to have the right access rights. Alter system requires system administrator rights, or alter session, you can do it for your own user session. And this is the script. No need to copy it because the Docker generating processes, either on the command line interface or with the use of AI Lab, are giving you the full statement. You just can copy and paste. So for the demo, what we want to achieve, first of all, now we have an idea what a user-defined function is and how we can utilize it. But for the demo, we need to discuss what we want to do here. Imagine you are a fund manager having a portfolio of maybe 100 companies. You always have to look for new candidates you can invest into, but you also have to look into companies you're invested into, and you have to decide if you want to keep them in your portfolio or if you want to de-invest. In other words, you want to sell this one. There are hundreds, if not thousands or hundreds of thousands of ad hoc news in the internet. On tickers, you have the general statements of the general financial statements and everything else. Even if you're in a team with several people, the number of documents is way too big that you can read everything. So we want to utilize a user-defined function to make a summarization. So giving you a short notice on what's going on and what is the text about. Here's an example from the Airbus company. It's a lengthy one. And here is the short summarization. And we want to even decide about the length of the summarization, if you want to have a more shorter one or a lengthy one. This is what we want to achieve right now. So how I'm doing this? I'm creating a user-defined function, first of all, with a skeleton, and using my own Docker language container by the name of Python 3 underscore OpenAI, because I'm using the OpenAI package to call, in this case, an external large language model server to let him do the summarization. I'm specifying here, as seen by the screenshot before, all my parameters, and I'm instructing him about my result. So in this case, a text, maximum 2 million characters. The next thing is I have to instruct the user-defined function to import a specific package. And then I'm just doing the client call and returning the answer. This is everything we need to do. And then we are good to go. How do I call the query? Just in a select statement. I'm doing a select statement here with iproc, which is giving me back the node on which database node the text has been processed. And then I'm calling here my UDF OpenAI underscore X underscore LLM for external LLM with my server, which is most likely here locally on my own premises with the API key. I'm using LM Studio, which does not require any kind of an API key. I'm instructing the LLM what to do by telling him, hey, aggregate the text messages a maximum 20 words. It will not always be exactly 20 words. It's just a rough guideline. And I'm telling him which model I have to use or which model the large language server like LM Studio should use. And this is the financial statement, the ad hoc news, the report, or whatsoever. And here is the table where everything is being stored into. That's quite simple. So how does it look like? First of all, I have here my texts. Let's go for the first one. So here, and you see the text. Yeah. And this one I want to summarize. So I'm going here again to the function. I can even, or I would be able to recreate it. This is everything you have seen before on the slide. First of all, I have to activate per session my strict language container I just defined. And this is the lengthy string which the creation process is returning. It's just inserted here by a copy and a paste. So, okay, the timeouts come in again. I just need to reconnect. I apologize. Apologies for this one. I just want to reconnect to the database. Okay, here we go. So once again, I have to enable this script language container, yeah, which has been successfully done. And now, for the time being, I'm taking just the first text ID, which is the one with the errors, and let him doing the execution. What happens? He's activating the Docker container, doing the call to the external LLM, which is waiting on a listening mode, and then he's returning the result. And I could even go and say, hey, I want to just have 25 words. Let's do it again. And then you will see that it's probably a little bit longer. If I'm doing 100 words, the text should be longer than before. Yeah, which is the case. So I can a little bit control this one. And now I could even go and say, I want to comment this out. And starting it again, which is taking a moment, because the large language model server is now doing all, I think, 10 documents at once before returning the result. And you will see that the documents are being stored on different nodes. So this has been done in parallel. Yeah, it's taking a moment. We can just look, here we go. So we have 2 documents being processed on node number 0. We have 2 being processed on node number 1, and so on and so forth, and only 1 on node number 4. And this is a way how you simply can extend the functionality of a database. So it's not all about, for example, connecting to an external server, but sometimes this is really important. For example, you want to do a data analysis with the currency exchange rate at this given point of time. You need to go to an external system, ask for it, and then doing the analytics on this one. And this is really then the way how to go with a user-defined function. Pretty smart, pretty simple. That's it. I want to thank you for your attention. And first of all, if you want to build your own Docker container, use the Exasol AI Lab, which you can find on GitHub. On the Exasol GitHub, it's published publicly in the internet. Or go to our community forum and you can ask the questions. We will answer your questions if you have any problems. And then start. And if you do not have an Exasol database right now, go to the download section of the Exasol homepage and download the so-called community edition. And then you're good to go. Thank you so much and happy Exasoling.